on how it's made. Plastic bottles and jars. Containment is the operative word. Mail. You know how it's made, we'll show you how it's sorted. Eggs. It's just one big shell game. And handcrafted wooden pens, the making of a signature product. Whether you're buying apple juice or peanut butter, you've probably noticed that fewer products come in glass containers these days, and that more and more items come in plastic packaging. Plastic bottles and jars are lighter to carry and leave no shards of glass to clean up if you drop your grocery bag. Many transparent bottles and jars are made from a type of plastic called polyethylene terephthalate, or PET. An automated mixer combines PET pellets with flakes of recycled PET. Reprocessed plastic loses some of its physical properties, so the recycled content can't exceed 10%. The PET drops from the mixer into a plastic injection machine that heats it to a piping 315 degrees Celsius. The dry raw material melts into thick and gooey liquid plastic. The machine then shoots it at high pressure into a mold. This plastic injection molding process casts pieces of plastic called preforms, starter shapes that subsequent machines will transform into bottles or jars. The molded preforms harden almost instantly, thanks to a built-in cooling system. These preforms are now on their way to becoming single-serving juice bottles. This is another plastic injection molding machine. It uses the same method to make preforms for a different model, 1.5 to 2 liter bottles. The preform's next stop is a machine called a reheat stretch blow molder. In a matter of seconds, it heats each preform just enough to make the plastic malleable, then inserts a rod to stretch the preform lengthwise, while at the same time blowing in air at extreme high pressure. This forces the preform into a bottle-shaped mold. Cold water circulates within the mold to cool and set the plastic almost instantly. This lightning-fast machine churns out 10,600 bottles per hour. No wonder we've had to show it to you in slow motion. A conveyor belt transports the finished bottles to the packaging area. Before blow molding, the preforms for certain models first pass through an oven. A technician sets the heat level of each infrared oven lamp individually, applying more or less heat at various points to influence the thickness and shaping of the plastic. From the oven, the preforms go into another reheat stretch blow molder that transforms them into peanut jars. It's the same process for this peanut butter jar. After molding, the machine instantly cools the plastic, locking in the shape. The factory pulls samples off the line at regular intervals for quality control testing. Technicians measure the thickness of the plastic and perform a compression test to gauge its strength. They verify the sample's dimensions and capacity. They also evaluate resistance to vacuum pressure because containers are often vacuum sealed after filling. Some models must also be strong enough to resist the pressure of their contents, carbonated soft drinks, for instance. The recycled material used in making these bottles and jars doesn't come from used plastic containers. For hygienic reasons, the factory recycles only new plastic left over from its manufacturing process. The finished containers, of course, are fully recyclable. They're typically reprocessed into other plastic products or into products that contain some plastic. What do the letters F, D, I, O, Q, and U have in common? Besides appearing together on eye charts, those are the only letters you'll never see in a Canadian postal code. They're too similar to some other letters and would confuse the machines that sort our mail. The trucks unload the containers they picked up from postal outlets and the bags of mail they collected from public mailboxes. The containers go straight to automated sorting because the contents have already been classified by size. Not so for the bags. Postal workers empty them and put standard size envelopes on a conveyor belt leading to one sorting machine, and large envelopes into a bin destined for another. The standard size letters travel to a high-speed, high-tech machine that first checks for postage. Stamps contain an invisible fluorescent material that illuminates under ultraviolet light. The machine's UV sensor scans both sides of every envelope. No glow, no go. Letters with postage are cancelled with a postmark so the stamps can't be reused. The postmark contains the date, the country, and the sorting plant's postal code. Next stop, a machine called the Multi-Line Optical Character Reader, an